And we can go live. Ready to roll?
Yeah.
And we're live. Welcome, everybody. And apologies for letting you all wait a couple of minutes. We were trying to get the YouTube live started and we failed. But I'll try to figure out as we go along as Viktor kicks this off. Feel free to say hi in the chat. Tell us where you're joining from. Hi, Viktor. Where are you joining from, actually?
From Barcelona, Spain.
Nice. Same here. Madrid, Spain, though. So the big right.
Close.
Yeah. Yeah, I see people using the chat. That's great. Please make sure that if you send stuff to the chat, you send to everyone, not to host and panelists, so that everyone can see. You know, we'll go through the presentation. Viktor will go through his slides. If you have any question, you can drop it in the chat. You can also use the Q&A functionality, which tends to be a little bit better, because then we can actually queue stuff up and people can upvote it, and it's a little bit more organized. But we'll try to incorporate things as we go along, or we'll answer them in the end in the Q&A. And yeah, I mean, as usual, this thing is being recorded. We'll send it over tomorrow to you per email, so don't worry about you know, we'll also send any useful resources, links, whatever. So don't worry about, you know, taking notes or whatever. You know, just stay in the chat, stay in the presentation. We'll worry about the rest. Awesome. I think that's it. I mean, I'm excited, Viktor. This is a big question that you're trying to answer today.
Silly question, but maybe not so much. We'll see.
We'll see. Yeah. Fantastic. We almost have over 100 people already, so I think we can get going. And I'll shut up and disappear, and the show is yours, Viktor.
Brilliant. Okay. I'll do my best to be brief, so that I have more time left to answer your questions. So, and the more questions, the better, right? I really don't like speaking alone for an hour. It looks like I'm in a bathroom with a mirror. Anyways, let's get going. Let me see. How do I share this? Share screen. There we go. Okay. So here we are, right? And the big question I want to answer that sounds silly, but we'll see. Maybe it's not that much, is what is Kubernetes? Now, before I jump into that question, very quick introduction for those of you who don't know me. My name is Viktor. This is how I look like after speaking with customers. I work for Upbound. We're a company behind Crossplane. You will see Crossplane as well today, but this is not focused on Crossplane. Twitter, I don't know, how do you call it? Subscribe to Twitter or whatever the name is. I'm also part of a couple of groups, not really important. Brought some books. I have a podcast. Podcast is important. You need to go and listen to the podcast. I think it's really cool, DevOpsParadox.com. And finally, I invest tremendous time in sharing stuff with the community in this YouTube channel. So check it out. Now, with that out of the way, Kubernetes, right? Now, what is Kubernetes? If I would probably ask this question in public, I would most likely get from many people one of the following answers, like Kubernetes is an container orchestrator, right? We have Kubernetes because we need to run our applications, package those container images that get converted into containers. So therefore, Kubernetes is something that orchestrates containers across a fleet of clusters. A fleet of servers in a cluster. And that's actually even what you will see in probably in the official documentation of Kubernetes, something along that line, right? Now, some other people will go with some more interesting, creative descriptions like, oh, Kubernetes is a cluster OS. It's an operating system that manages a group of servers as if they're one big server, one big cluster. That makes sense from certain perspective as well. Some other people are going to say, hey, Kubernetes is a control plane, and that's also a valid answer. All the answers I'm giving you so far are valid. The problem is that none of them really describes Kubernetes. Most of them describe somehow some of the features of Kubernetes, right? And in some cases, even in some use cases, some of those answers are not even correct at all, do not even apply. And you will see why soon. So what is Kubernetes? That's what we're going to. I'm going to start easy. I'm going to, at the very beginning, you will probably see me talking about things that, oh yeah, we all know that, but progressively, I will get to a very different place than where we started. So bear with me, right? Even if you know the very beginning. So let's, before I jump into Kubernetes, very quick, right? This is not Kubernetes deep dive, but let me go very quickly through architecture, right? Architecture is that we have a control plane. That's where the decisions are made. And we have worker node. That's where something might be running. But bear in mind the word might, because we can easily have Kubernetes clusters that have no worker nodes, where nothing is physically running, right? Perfectly valid combination. But in majority of use cases, a cluster means control plane and worker node. And then we have some external resources. Those external resources, I'll get back to them later. And then that control plane is, in most cases, 3 nodes for high availability. And then we have any number of worker nodes. That all depends really of what are we running in those clusters. So far easy, right? And then those external resources also can be many. We can have storage. Storage is not really part of that cluster. It's not server. It's something that is attached to workloads. We can have external load balancer and many other things, right? But in a most simplistic way, in most common way, the architecture is that control plane, 3 nodes, worker nodes, any number of them, and then some external resources. And then when we as humans use it, we always go to the API. In API, we request a specific desired state of something, right? So we don't say, even though we don't say do this, we say this is what I want the state of something to be. We have a scheduler that figures out what should happen, when should happen, where it should happen. That's decision-making part of the control plane. We have controller manager that manages controllers, which are crucial for this story because controllers can be many different things. And we have key value store, typically etcd, that think of it as a database of the state of the Kubernetes cluster. And then in worker nodes, kubelet, that's the one that runs containers. We'll get to containers later. Kubeproxy to make sure that communication is fluid, is going through all the processes, and of course the API. Container runtime, that's the one that runs your containers, and containers themselves. Easy. I mean, maybe not so easy, but and those containers are not run as containers. We cannot say run a container in Kubernetes. We can say run a pod, or I want to have a pod, and pod is a group of containers and a few other things. So one pod can have one container or multiple containers. In most cases, we talk about one container, maybe plus some side containers that do some additional activities, but typically one main container, right? And then we have controllers. Now, controllers are critical in this story because controllers are figuring out what to do when some resource is created, updated, when the resource changes its state. So if I say I want to run a pod, then through the API, then let me highlight this. Does this work? Doesn't work. Oh my God. There we go. We create some resource, a pod, and then a controller figures out what to do with the pod or the deployment or replica set. But there can be many others, and this is the key. So remember, controllers, resources are the key in actually this picture, which will become invalid very soon. So that's the most common architecture. Let's say. Now, let's see how that works in practice and where we are going to get. We're going to start with containers, but then move to something very different. So let me move this to a different screen and show you the command line, because every good demo is based only on a terminal, right? So let's start with applications, right? If you want to manage applications, we would do something like kubectl, namespace, production. We want to apply something defined in the directory silly demo in this case, right? And that directory will create, in that directory, there were manifests that created a deployment as a service. And if I say, get everything that exists right now in that namespace, we got essentially containers, right? Everything here that you see is somehow one way or another related with containers of an application. Deployment creates a replica set, replica sets create pods, run containers. It's all about, in what I'm running right now, it's all about containers, containers, containers. The only exception is the service that enables communication with that application in case I have additional applications in my cluster, right? So what we have right now is that I created the deployment created the replica set, and replica set created some pods. In this case, 3, because I said I want this application to run with 3 replicas. Now, let's go to something slightly different, right? I'm going to change the image. No, I'm not going to even do this. This is boring. I'm going to jump into infrastructure, right? Because so far, the definitions at the very beginning, Kubernetes is all about running containers one way or another, no matter how you phrase it, because that's my applications, starts to break down, right? And it breaks down because what I have right now, there we are, is 3 pods, right? I created a cluster with 3 pods. Doesn't matter whether there is a deployment, then replica set, essentially 3 pods, one with the container in each of those, right? So now, let's do this. Let's deploy a second application. I'm still not doing anything complicated. Production, apply, something defined in the directory dot, right? And this time I got a bit more, right? I got the deployment just as before. I got the service just as before, but I got ingress and persistent following claim for that application, right? And if I list everything in the directory, in that namespace, you can see that I have now 2 applications that are pods. These are the containers, standard stuff, but I got a bit more, right? And that more is I got additional pod, right? So I have now second application. That application can speak with the other one through the service. And, but I got this as well, right? I got, here we are, ingress. Now, what this means is that I instructed my application. I actually told Kubernetes, hey, my application should be accessible from outside of my cluster. And ingress is doing a slightly more than making it accessible from outside of the cluster. It is creating an external load balancer, right? So when I created ingress, here over there, I essentially instructed Kubernetes to create an external load balancer. Right? And since this is stateful application, I also created a persistent volume which went to my cloud provider or whichever provider I'm using and attached an external drive into that container, right? What that really means, and where I'm going with this, is that even with this simplest possible example, it cannot be true that Kubernetes is all about running containers, because I'm effectively already, with or without knowing, managing infrastructure, right? I'm using Kubernetes cluster to manage external load balancers, whatever those load balancers are. They're outside of the cluster, that's what matters. And to manage some external drive, external disks. So I'm already going beyond, and everybody is essentially, right? With or without knowing, I'm going beyond, hey, this is how we run containers. I'm already managing my infrastructure with Kubernetes together with the workloads inside of that cluster, which are packaged as container images, which become containers. Now, how about managing virtual machines, right? Because this example here is still, you can say, yeah, Viktor, you're right. You're actually managing some infrastructure outside of that cluster. So it's not all about containers in a cluster, but that infrastructure is directly related one way or another with applications running inside of the cluster. So it's still somehow about applications. It's just that there was a short trip outside the cluster to get some infrastructure. And that would be fair enough conclusion, right? But how about this? How about me using Kubernetes cluster to manage virtual machines? Let's say that my applications, for whatever reason, shouldn't be running in containers, should be running in virtual machines. There could be security reasons for that. That could be legacy reasons. There can be many reasons why I might want that, right? So I could, as a person, I could go to the cluster and say, hey, I want a VM. Nothing to do with containers, no relation with containers at all. I just want a virtual machine, and I'm going to do something with that virtual machine. And then that cluster would run, instead of running containers, it would run virtual machines inside of those servers. And I could combine that in parallel with what I had before. I could still have a cluster that is a number of servers that both runs containers with whatever is required for those containers, but also some virtual machines. And that's a good idea, because if I do that, I have a single pane of glass. I have single API where I can use Kubernetes API to manage different things, including virtual machines. Now you might say, okay, so this changes the game. This is not only about containers. Now it's about infrastructure a bit. It's also about running something that has no relation with containers, with virtual machines. So the first definition that I mentioned kind of falls apart, but it is still mostly somehow related with Kubernetes managing stuff happening in the servers that constitute that cluster, right? Because those virtual machines are still inside of that cluster, right? The only, in this diagram at least, external entity I have is external load balancer. Fair enough, but I can do more than that. I can manage external resources completely that are completely outside of the cluster. I can do something like this. I can go to that same cluster, to Kubernetes API, and say, hey, you know what? I'm going to use Crossplane for that. I would like more than virtual machines, more than containers. I want something that is not really running Kubernetes cluster, but I want Kubernetes because it has an awesome API, because it alleviates a lot of problems, and it helps me with a lot of things, which we can discuss later. Anyways, I like Kubernetes. I want to use Kubernetes to manage external stuff. So let's try to do that, right? If I do something like, let's say, I'm going to use Crossplane for that. How about this definition, right? This is typical, I mean, Kubernetes manifest that defines, whomever is using Kubernetes recognizes immediately that I'm specifying some API version kind, and I have some specification. The difference here is that I'm saying something that doesn't exist in Kubernetes out of the box. I'm saying, hey, I would like to create something called instance, and that instance is somehow related with AWS in this case. And here are some parameters I want to pass. I want to create a virtual machine, an instance of EC2. This is the ID of the image. This is the region. This is the size. And I want to use a subnet called my VM. And since to create a subnet, I will need a VPC. I'm going to specify that, hey, I would like a VPC as well with certain parameters. And I want a subnet, right? Also with certain parameters. And I want all those things to work together, right? And I can definitely do that through the controllers I mentioned before, because what many people do not really grasp initially is that everything in Kubernetes is managed by a controller that listens to certain specific resources being created, updated, deleted in Kubernetes API. And whenever I send a request for certain type of a resource, then specific controller will do something. And that something can be, as you saw before, creating pods with containers. It can be creating an external load balancer. It can be anything you want. And anything you want really depends on which controllers you install. In this case, I have controllers installed through Crossplane, but you could create your own controllers, like with Meta Controller, or you could use Kubevela, Cluster API, many, many other solutions. So if I do something like kubectl apply, file name is Crossplane examples VM, the same one that I showed before, I just send a request to Kubernetes. I said, I want to have those three things. I want to have an EC2 instance, VPC, and subnet. I'm going to assume, I'm going to guess that there is a controller in that cluster that will know what to do with it, right? That's not my concern anymore. So what I effectively did now is went to the cluster, said, I want to have something that is extended or extended resource in Kubernetes, or custom resource, right? Now, if I now list and say kubectl get all the instances and VPCs and subnets, you can see that just as when I manage containers, no, subnets like this. Okay, there we go, right? We can see that the controllers responded with the information like the status and what's or not. This VM is being synchronized, but it's still not ready. It's not fully operational. The VPC is there and subnet is there. You need to trust me. I can show you later on the screen. All those things are being created in my AWS account right now. So, so essentially what happened is that I requested something from a cluster, a VM in this case is 2 instance, a cluster went to the API, in this case of AWS, and requested that something be in the specific state, right? And AWS in this case created a virtual machine. So nothing is really being created, no workload in this example is running in Kubernetes cluster. Kubernetes is neither about running, in this example, about running containers, nor my applications, nor anything else. It is just a management tool, a platform that allows me to manage resources and make sure that everything is happening in the correct order, what's or not, right? So how about I do something else? I do say something, hey, how about you create a database for me, right? Or put make sure the database is in a correct state, actually, rather than create. So we can do that as well. I can say, hey, how about this crossplane examples, Postgres, right? Let's say that I want the Postgres database. Very simple, actually slightly more complicated, very simple, easier for the end user, but this time I'm doing something very different, right? This time, instead of in the past, what you saw before, I used predefined controllers created by somebody else to create EC2 instance and subnet and VPC. But in this case, I'm not using third-party controllers. I'm using a controller and a custom resource definition that I created myself, right? You can see by the API version. This is mine. This doesn't come out of the box from anywhere, right? And I created a new resource type in Kubernetes that's called SQL claim, and that resource can certain parameters. It can select the implementation. Like in this case, I want AWS Postgres. It could be a different implementation, and I want, since somebody needs to use the database, to create a connection, Kubernetes secret called MyDB with the authentication information for that database, right? So I'm going now a step beyond and saying what comes out of the box is not good enough as the only exclusive usage for me. What comes as extensions of Kubernetes out of the box from some third-party solutions, in this case, Crossplane, is not good enough either. I'm going to create my own definition of what that something is. And this is going to be awesome because this thing will help everybody else in my company to create and manage databases by themselves because it's easy, right? There is a complex stuff happening behind the scenes, but from the user perspective, it's extremely, extremely easy. So I can apply this just as before. I'm going to use namespace production. I'm going to apply whatever is defined in the name Crossplane examples PostgreSQL. There we are. That DB SQL claim was created. Remember, this is a custom resource created by me, right? And if I list all the claims or SQL claims, namespace production, get SQL claims, there we go. You can see that it is not yet ready. It takes time until database and all the resources are created in AWS, but it will be done at one moment soon, right? So going back to the diagram, what did I do right now? I said, hey, I want a database cluster, Kubernetes itself, went to the API of my provider, whichever provider is, said, hey, there should be the database, and it should be a bunch of other things like subnets and whatever is needed for that database. Do it for me. How about I go a bit further and say, hey, how about I use Kubernetes to manage other Kubernetes clusters? Go and create a Kubernetes for me. And we can do that as well. I can do something like cut crossplane examples, AWS CKS YAML. There we go, right? Again, custom resource definition made by me because I want to make it easy for everybody in my organization. You just need to say, hey, I want a cluster in AWS CKS. I want it to have medium-sized nodes. I don't know what that means in AWS, but whatever is something medium, and I want to have 3 nodes. And then if I apply this, kubectl namespace production, I want to apply whatever is defined in the file. Crossplane is examples, AWS CKS, right? And that's something will be created. That single resource will reach the API, controller picked up that request and figured out what needs to be done. Again, a controller made by me, custom made, right? And I can list all the cluster claims in that namespace, get cluster claim, and you can see that my cluster called ATM EKS is right now creating a control plane. When it creates a control plane, it will create a node pool and so on and so forth. So what happened is I went to the cluster, call it management cluster at that point, said I want a Kubernetes cluster, a second one. It went to the API of the provider, whatever provider is, and it instructed it to create all the resources required for that cluster. Now, if I say, hey, you know what? Give me everything that is managed right now by that cluster. I want to see all the stuff that my Kubernetes cluster is managing at this moment, right? Because remember, what did I create so far? I created an application. I did not create a VM because I did not prepare the demo for that. So I have 2 applications right now running. I have SQL claim, I have a VM, and I have a Kubernetes cluster, right? But when you look at what is managed by that cluster, which will take a while, you can see that I got a lot more, right? All those things that I requested that looked easy actually got translated into what, in this case, in this demo, is required by the by AWS, right? I have 2 internet gateways, one for the database, another one for the cluster. I have security groups that are managed right now by Kubernetes in AWS, a bunch of subnets, 2 route tables, one for the database, another one for the cluster. What else? I have 3 VPCs, 1 VM, that's the VM that I created earlier, 1 cluster that is being created right now, node group for that cluster. When that cluster is created, I will have some Helm charts installed. I have some roles, policy attachments, some Kubernetes objects that will be applied to that newly created cluster whenever it's finished, subnet group for the database, and RDS instance. So a lot of things happening, a lot of things that are managed by my Kubernetes cluster, and only a fraction in this demo are actually containers and my applications running as containers, and my cluster serving only and exclusively as a way for my applications to run their packages as containers. So if I go back to the question from before, what is Kubernetes? All of a sudden, the answer, and this is now official, a container orchestrator in charge of operating a fleet of containerized applications is not true, right? This is simply not true because in like 15 minutes demo, I showed that could be, apart from containerized applications, there was some external load balancer for that application. There was storage. There were some virtual machines. There were some databases in AWS. There were some other clusters. And those other clusters and databases had VPCs and subnets and internet gateways and a bunch of other things. So it's certainly not correct, this definition. Again, this is from Kubernetes IO. It is not about operating only exclusively a fleet of containerized applications. That's just the first association many of us have with Kubernetes. So if I go back to the question, what is Kubernetes? The real answer is that it depends. What is Kubernetes greatly depends on what controllers we have in Kubernetes. If we have a controller that will fulfill the requests related to containers, then that's what it is. Then it's about containers. If we have a controller like Ingress that manages external load balancers, then actually it's something else. If we have a controller for virtual machines, databases, what's or not, the story changes all the time. So the definition of Kubernetes cannot be based on what we are running and what are the types of resources it manages, because it all depends on controllers. It can manage everything and nothing and anything in between. So a Kubernetes cluster might manage only containers. That's what many people are using it for, right? Or it can manage containers in infrastructure. The moment you add Ingress, for example, or persistent storage, it's both. It can be used, and there are quite a few situations where it can manage only infrastructure without any containers even running there. It could be virtual machines, or it can be something completely different. For all I know, you can create a controller that will be running in a Kubernetes cluster that will be in charge of your orders to Pizza Hut or whichever fast food joint you prefer. So it is definitely not only about containers. It is about controllers and the API and control loops. Those are the things, the components in Kubernetes cluster define what it really is. Controllers allow us to define what should be controlled and managed by Kubernetes cluster. API allows us, which by the way is highly extensible with custom resource definitions, allow us to have a single place of contact, a single API essentially to manage whatever we want to manage, whatever that is. And control loops are the mechanisms in the cluster that allow it to manage something, right? Because one thing is to say, create a virtual machine for me, and then it creates it. That's only part of the story. Control loops allow it to make sure that that Kubernetes cluster is, whatever that resource is constantly monitoring that resource and continuously making sure that the state of that something is always whatever we want it to be, right? So what is Kubernetes? Slightly better definition could be, it is a control plane for whichever resources we might need to manage. Doesn't matter what the resource is, we can manage it with control plane, and that control plane is Kubernetes. That was my very quick rant. I wanted to be very, very fast so that I hopefully get questions for you and I can answer the questions. Otherwise, I will feel embarrassed that I didn't talk and extend the demo. Right. Before the questions start pouring in advance, thank you so much. If you want to check where I work, that's Outbound. Crossplane is one of the tools I showed you today. Remember the podcast and the YouTube channel. Now, I will try to answer all your questions if there are any. Please don't make it embarrassing.
Thank you, Viktor. No, and there are some. I'm just gonna start reading some of them out. There were some really good action in the chat, but people are also quite disciplined, so use the Q&A. So Kale Razan is asking, hey Viktor, if the Kubernetes cluster of VM is initially built in Azure with the full security gateway settings, is there an option to go back and amend the security settings to get the cluster behind firewall, for example? In other words, how can we make the cluster secure if it was initially built with default security setting gateway, with default security gateway settings, sorry, and make it CSI hardened image?
I mean, that depends really. There are many ways how to secure Kubernetes cluster, right? You can secure it by having a secure distribution of a cluster. I prefer Talos, for example, when I'm not going to manage Kubernetes. You can have admission controllers that will ensure that whichever request to going to the cluster is served only and applied only and exclusively if it meets certain policies. You can use something like Averno for that, or OPA Gatekeeper, or Datri, which recently released admission controllers, and so on and so forth. So I cannot give a blank kind of to this. But if you want to ping me after the chat and tell me a bit more about your situation, I can be of more help, I think.
Nice. I'll pick one from the chat. So Dale is asking, what is the best language for deploying code in Kubernetes? What do you find is the easiest to define your desired states? Is it YAML?
So yeah, it can be. So let's start with this. Kubernetes itself accepts only and exclusively YAML or JSON. So you cannot send something written in Go to Kubernetes, or at least not that I know. So it must be YAML or JSON. Now the question is really, first, if you write something directly in YAML, how do you write that? Is it just YAML, or is it, or do you want to use some kind of overlaying with customize, which is one of my favorites, or something like templating with Helm, which I personally trying to move away from? Or you can use some completely different language and say, hey, I want to manage stuff with JSONnet, right? Or Go, or JavaScript, or anything else. Now, in those cases, that anything else, you still need to produce YAML, right? But your source is something else, and then it's the responsibility of that tool to transform it into YAML and then pass it to Kubernetes API, because that's what Kubernetes API understands. So, for example, you can use JSONnet with Tanka, which is extremely powerful, with a relatively steep learning curve, and define everything in JSONnet. Now, Tanka is going to transform it into YAML before pushing it to Kubernetes. I hope that answers your question. If I don't answer, maybe sometimes I don't understand the question well, so you can just ask the follow-up.
Nice. All right, so back into Q&A. Micha is asking, one question, is the initial Kubernetes cluster hosted on Prem?
Can you say again, sorry?
Is the initial Kubernetes cluster hosted on Prem? I'm not sure I get that. I'm not sure.
Okay, if the question is about the cluster that I used, it's embarrassing. I used Rancher Desktop, like local Kubernetes cluster here. But that initial cluster can be anything. I use today local. It can be on-prem, it can be cloud. Doesn't really matter. You can, and also you can use those same controllers that you would use to manage other Kubernetes clusters. In this case, with Crossplane, you can use to manage that initial cluster as well. So it can be any Kubernetes cluster. This is the beauty of Kubernetes. Doesn't really matter where it is.
And what created the other resources in the cluster? Is it your controller? And when they're created, it syncs them?
Yes. So what I did is that I used something called, I did not want to go deep because I wanted to make this generic and not to be kind of locked into a tool. But specifically what I did is that I used Crossplane compositions, which allow me to define a new interface, a new custom resource definition, that simple one, and then say, hey, whenever somebody requests those 10 lines of YAML, you should expand that into a bunch of other things. I can show actually on a screen. Let me see one example. For example, the EKS cluster that I created, I have it, which directory am I in now? Okay, I need to go somewhere else. DevOps Toolkit, Crossplane. It will take me a second. packages, Kates, EKS, YAML, right? So that cluster, the last example I created, same applies to everything. When I defined those 10, 15 lines of YAML, what really happened behind the scenes is that it figured out, oh, that's a controller you just created, and that controller should actually create all those things like EKS cluster over here and a bunch of parameters and node group and so on and so forth, right? I don't know whether that was the question. And yes, all those resources are individual resources. No matter what is the parent, you have parent resource like cluster claim in my case, and then child resources, and those child resources you can have other child resources. But what matters is that each of those resources, when I showed you managed resources, like there were 50 or more of them, each of them has their own controller, or one controller can actually manage multiple resources, and they all go to control loop. They are all actually syncing individually with whatever they should be syncing.
Jivan is asking, can we read private EKS clusters API without any agent running in the cluster?
Can we read private? I mean, you mean, can you access a private API that is not accessible? Is that the? I'm not sure I understand the question. I'm sorry.
Jivan, maybe if you want to elaborate either in the Q&A or in the chat, let us know. Dennis, when creating a cluster of VMs with Kubernetes Crossplane, how are these VMs managed within the Kubernetes cluster? How are they treated differently than pods?
Yes, I mean, again, depends on the technology you choose, right? VMs can run as containers in a Kubernetes cluster. That's one option. You can use KubeVirt, that would be a different option, or you can use, or the controllers can be managing VMs completely outside of the cluster, like in my case with EC2 instances, right? So again, it all depends on which controller you install, and there are a bunch of them. Then where VMs will be created will differ greatly, but it can be directly on the machines of the cluster itself or outside.
All right, so Jivan, I think, reiterated. So if we want to read all Kubernetes objects in a cluster, which is private in EKS from outside of that AWS account, is that possible? And if yes, what is the best way?
To read all objects, to read all objects, as if list all objects, give me everything running in a cluster, that would require some third-party app, because Kube API does not allow that. When you say list all, you're assuming that I understood your question, you're actually getting only a handful of resources. So it would need to be some kind of third-party tool or some shell script that iterates, ask the API what are all the types of resources, and then all the, kubectl gets CRDs and then go through each of them separately. Assuming that I understood the question. If the question was, can I list all the resources managed in a Kubernetes cluster, not with out-of-the-box kubectl.
Luca, great name, asking, what patterns would you apply to separate different product teams on your cluster, not to interfere with resources of other teams?
So the easiest and obvious is namespaces for each team, but that can be problematic on many levels. What I would do for teams, assuming that giving each of the teams separate clusters, I probably use vCluster. vCluster allows you to create extremely efficient virtual clusters inside of the cluster. So from the user perspective, if I give you kubeconfig of a vCluster running in my cluster, all you would see is what is inside of that virtual cluster. From the user perspective, it would look and feel as a real cluster. But from the operational perspective, that cluster is a separate cluster running in a container with all the resources being created inside of that container, except pods themselves, which are on the namespace level. So vCluster is from Loft, I believe, is what would be my first attempt.
All right, we can jump over to the chat for a couple of last ones. So Dua is asking, do you think it is possible to create a generic provider for a specific API? That means there's only one generic type in API with different attributes, and we patch some of these attributes from a composition depending on the resource that we want to create.
So assuming that this is not related to, this is in general, but not related to Crossplane, yes, you can do that. I forgot now the exact parameter, but when you're creating a custom resource definitions, without me remembering now the exact phrasing, you can specify that any schema is acceptable within the spec section, right? So you can create one custom resource definition that basically accepts anything in spec. That's doable. Or you can go with something more elaborated, maybe like kubevela, for example. If you use kubevela, then everything is only one and only one API, which is application, kubevela application. But that application can have infinite amount of permutations depending on how many components and traits you created. And that would also be a way to create one API only, generic kind, let's say.
Osman, which steps are involved in creating a custom controller and API to deploy customized resources?
So steps depend on the tool that you use, right? You can write everything from scratch. You can use something like Kube Builder that will help a bit. You can use Crossplane, which is what I use today. You can use kubevela, or if you don't want anything, something much more generic, my favorite today is Meta Controller. So the steps really differ depending on the tooling you use, but there are always two generic steps. You need to create a custom resource definition. That's just pure YAML. It's extremely easy. That tells Kubernetes now that there is a new kind of resource, whatever that new, call it Viktor, for example, or platform. And then once you create that custom resource definition, again, it's easy. You need to create one or more controllers. And that's those controllers, for example, if it's something very generic, something that is not specific, if you use Meta Controller, that would be one simple YAML that is pointing to any container in a cluster, and we'll be sending requests to that container. And then in the logic in that container would be doing whatever you want it to do. So summarize, create custom resource definition YAML, create YAML for a controller. If you're using Meta Controller, that's the easiest one. And then you have a container with something, right? What is that something depends what you want that controller to do.
All right. Osman, also a great question. So Kubernetes ecosystem is full of different third-party systems and frameworks. Is there any overview in which you can serve like pick the framework based on the use case?
I mean, I cannot answer the question because that would be for anything, right? But if you ask me for something specific, then I can answer kind of at least what is my preference. Like if you ask me, oh, what is the one for GitOps? So what is the one for CI/CD, or what is the one for this or that? Then, but it's a bit too generic to answer because my ideal, if I would be building now ideal cluster, that would already have quite a few components. I would probably use Kyverno for policies, Crossplane for external resources and compositions. I would use probably Trivi for security scanning, and Argo CD or Flux. I'm always undecided for GitOps and so on and so forth. So it's if you're assembling it yourself, there are quite a few things you need to think about, or you can get a ready-to-go platform kind of that already made those choices for you.
All right, so Dale's asking, so using Kubernetes makes having persistent state possible across multiple resources. So if, for example, a VM gets shut down, does Kubernetes reprovision it automatically?
Yes, if a VM gets shut down, Kubernetes will communicate with the API of this provider that you're using and say, hey, give me a VM because I have 3 and I'm supposed to have 4, right? So yes, Kubernetes will do that, will reprovision the VM.
Kenneth, yes, we'll make the recording available tomorrow morning. Dua is also asking, do you think, oh no, we already answered that actually. And then Gven's asking if managing infrastructure with Kubernetes is better than managing with Terraform. I think it's a bit of a different thing.
Yeah, I wouldn't now go into what is better or worse. I like Kubernetes. I think that the question, it's hard to answer the question today, right? What I can answer easily and without being limited to infra is that we are going towards a world where more and more stuff is managed by Kubernetes. Let's put it that way.
Yeah, and I tend to agree. Fantastic. I think that was it. Thank you so much, Viktor. Really appreciate it.
Pleasure.
Thank you everybody for hanging around. I think so as I said, we'll follow up tomorrow morning with everything. If you have any follow-up questions, feel free to follow up per email. You'll find Viktor on Twitter, but also on the Platform Engineering Slack. So I'll drop here the link. That's our Slack channel. If there's any questions that you want to ask Viktor or anyone else, feel free to jump in there. Viktor, thank you so much for doing this again. And I'll see you around.
Thank you for having me.
All right. Have a good one. Bye-bye.
Cheers.